Oh, man. Take your own time there, Steve. Okay. All right. Don't trip. Don't want anybody tripping.
Can you switch back to that?
Sure I can. Okay. So when we're trying to simplify this, what do we do with the 2 and the 14? We divide, right? Because as we've studied, the power in a fractional exponent, the power is on top, the root's on the bottom. That's why I drew you a picture of a tree, because the power of a tree is in the numerator, and the roots are under the ground. So that image is hopefully what will help you remind yourself. It's power over the root. Now, you don't have to write a to the 14 over 2, because most of the time you'll say 2 goes into 14 how many times? 7. How about 2 into 16? 8. And it's also true that it's 16 over 2. But this is what we're looking for. If it helps you to understand that it's power over the root, then do that. Okay, what about the next one? What do I do to both sides? Take the square root. What's my answer? Plus and minus 8. Thank you for coming up with 2 real solutions. Make sure you're writing things down so that you can have it for the test. Okay, now, in this particular situation, 63 is not a perfect square. But there's a perfect square trapped inside of it. That's true. That's true. Now, I showed you what I did when I was in middle school. Some of you like to do factor trees. You like to break it up into 9 and 7, and then 3 and 3. I did upside down division. 3 goes in 21 times. 3 goes in 7 times. However you like to do it, you will circle your pairs. And yes, a 3 comes out. What's trapped inside? 7's trapped inside. Okay, now that 2 that's on the outside, 2 goes into 9 how many times? 4. With how many x's left over? 1. Now here I'm going to have to put them together. Right? What's 6 times 12? You're not taking notes. This is ridiculous. 72. And then if I've got this x and I put them together, what do I get? X to the 5th. All right, now we need to break it up. Whichever your preferred method is. That's right. So if I did it this way, I would end up getting the same result you just mentioned. A pair of 3s and a pair of 2s. Same thing if you did your factor tree, broke it up. 36 and 2, maybe you did 6 and 6. And then the only thing I don't like about factor trees is the fact that people get lost in their information. And they don't say, oh yeah, there's a 2, and there's a 3, and then I've got a 2 left over. So yes, so you get a 2 that comes out and a 3 that comes out. What's 2 times 3? Question? Anything? 6 comes out. What's trapped inside? If the 6 comes out, what's trapped inside? 2. The index that's out here, 2 goes into 5 how many times? 2 with how much left over? 1. All right, multiply those together. Show me what you get. Whether you FOIL or whether you like to do a box. Or line them up like the elementary school version. What did you get? 20 is correct. Now, yeah, which way would you like me to do it? Would you like me to do it the box? Okay. I'll just do it on top because there's more space. Okay, so 5 times 5 is 25. 5 times radical 5, ain't much you can do with that. 5 times negative radical 5, negative 5 radical 5, those cancel. And then what is radical 5 times negative radical 5? If you say negative radical 25, which is correct, what is that? Negative 5. So 25 take away 5. 20. Now, whether you like a box or you like to draw arrows, it doesn't matter to me. Or whether maybe you like to line it up in the old, elementary school version, where we keep our terms together and, you're going to do it like this and multiply these two and these two and those two and those two. That makes no difference to me. It'll all come out to be the same. Yes? Okay. All right, so at first they don't look like radicals. What can you do with this 20? What can we break it up into? Any perfect squares inside of 20? 4 and 5, and we know that radical 4 is 2, so we do have 2 radical 5, which is what you just quoted me. How about the 45? That's 9 and 5, right? So 3 radical 5. And then, of course, you got minus radical 5. How many radical 5s is that? Nope. Add them up. 2 plus 3 minus 1. 4 radical 5s. Please make sure you're writing things down as we go. No. There are 3 parts. Which one of those is the root? The 3, right? We're talking a cube root. Which one of them is the power? The 5. Okay? What does the negative 1 do? It flips it over. Okay? Now, so we're dealing with a cube root. All right, what else? Power of 5. If this is all over 1, when you flip it, it becomes under 1, right? Which answer choice is it? D is one of the 2 acceptable answers. There is another. Which one? A is also acceptable. So I'll give two answers on that one. How do you rewrite radical 7 as a power of 7? We'll make this our last one. 7 to what fractional exponent? 1 over something. What's the index on a square root? The index on a square root is not a 3. Right here, it's a 2. So that'd be 7 to the 1/2. Okay, now, how about this one? The 6th root. That's 7 to the 1/6. When we multiply like bases, what do we do with the exponents? You add them together, okay? Now, 1/2 plus 1/6. What do? Common denominator. We can multiply this one by 3, and we will have a common denominator. So this would be 7 to the 4/6. I would take that answer. I would take this answer. What are the radical versions of those answers? And I would accept both of them.
It'd be 3, 7, 2. So 3 on
Okay,
the
so 3, you mean a cube root of 7 squared? What's another one I would also accept?
the actual answer.
Right here, folks, what would the radical version of that be?
6,
6th root,
7,
7
4.
to the 4th. I would take any one of those 4 answers as long as you're showing me the work. No, there's no negative exponents. No negative exponents.